Lesson 5.5, Solving Trigonometric Equations. Example 1, solve the equation 5 sine x equals radical 3 plus 3 sine x. The first thing I'm going to do is subtract 3 sine x from both sides of the equation. When I put this together, 5 sine x minus 3 sine x, I get 2 sine x. I'm trying to solve for x, so I'm going to divide by 2. So I get that the sine of x is equal to radical 3 over 2. So what I'm trying to figure out then is what angle is going to land me at radical 3 over 2. So referring to the special 30, 60, 90 right triangle, sine is opposite over hypotenuse. So the 60-degree angle has an opposite over hypotenuse equal to radical 3 over 2. We're going to want to convert to radians. So 60 degrees is equivalent to pi over 3 radians. We did this in the previous chapter, multiply by pi over 180 and reduce to lowest terms. And then we have to consider that the sine, which is the y coordinate, is positive in both quadrant 1 and quadrant 2. Because here's the y-axis, and here's where the y-axis is positive. So using 60 degrees or pi over 3 as a reference angle, then a turn of 120 degrees would also land you at radical 3 over 2. And 120 degrees would be 2 pi over 3. So my two solutions are pi over 3 or 2 pi over 3. Now, how we want to express this is pi over 3 plus 2n times pi, comma, 2 pi over 3 plus 2n times pi, where n is an integer. So why am I doing this? Well, the period of sine is 2 pi. So what that means is if I turn 60 degrees and I land at a y coordinate of radical 3 over 2, but if I add a full rotation, 360 degrees or 2 pi, I land at the same place. And you can keep doing that again and again. So that's what this is expressing, that I can keep going around the circle an infinite number of times and land at the same spot. Example 2, solve the equation tangent of 2x is equal to radical 3. Now notice in this problem, they're restricting x. So we won't have to do this because we're limited with our solutions. The first thing you want to do is, instead of thinking of it as 2x, think of it as just theta, the name of the angle. So we want to figure out what angle has a tangent of radical 3. And going back to our 30, 60, 90 triangle, remember tangent is TOA. It's going to be opposite over adjacent. So opposite over adjacent, 60 degrees, would be radical 3 over 1, or radical 3. So once again, 60 degrees, which we're going to convert to radians, which is pi over 3. Now we want to solve for x. So set 2x equal to pi over 3, divide by 2, and you get pi over 6. Now, there will be multiple solutions on this interval, and how we're going to figure out what those are, we know that the parent function, the tangent of x, has a period of pi. So because of this coefficient of 2, the period of this function is going to be pi over 2. So we are going to add pi over 2 to pi over 6, and we'll do that as many times as we can, staying within one rotation on the circle. So we're going to add pi over 2 each time. And remember, pi over 2 is equivalent to 3 pi over 6, getting the same denominator. So we're going to end up with 4 solutions. We started with pi over 6. When we add pi over 2, which is 3 pi over 6, we get 4 pi over 6, which in lowest terms is 2 pi over 3. Then 4 pi over 6 plus 3 pi over 6 is 7 pi over 6. And then 7 pi over 6 plus 3 pi over 6 is 5 pi over 3 in lowest terms. It's 10 pi over 6, but reduce it to lowest terms. Make sure you give your answers in radians because that's how it's being expressed. Okay, in example 3, we want to solve the equation sine of x over 3 is equal to 1/2 on the interval 0 to 2 pi. So this is just another way of saying this. In other words, we're within one rotation. So once again, think of it as the sine of theta equals 1/2, where theta is taking the place of x over 3. For right now, just to figure out what this is, what angle gives us a 1/2. Looking at the 30, 60, 90 triangle, so katoa, sine is opposite over hypotenuse, so it's 30 degrees, which is pi over 6. So theta is pi over 6. Now set theta equal to x over 3. So x over 3 equals pi over 6. Clear the fraction, and 3 pi over 6 reduces to pi over 2. Now this is going to be your only answer because we are limited to this interval. And the period of this function is 6 pi. How am I getting that? The parent function, the sine of x, has a period of 2 pi. The way that you make the adjustment when you've done something to x is to take 2 pi divided by the coefficient of x. Well, the coefficient of x is 1/3. To divide by 1/3 is the same as multiplying by 3. So obviously I don't want to add 6 pi to this because that's outside of my interval. Okay, example 4. Solving this equation, 2 times the sine squared of x minus 3 sine x plus 1 equals 0 on the interval 0 to 2 pi. I want to factor. So basically, what did it look like before the FOIL method? After you factor, set each of the factors equal to 0 and solve. So either 2 times sine x minus 1 is equal to 0, or the sine of x minus 1 is equal to 0. So add the 1 to both sides and then divide by 2. And once again, for this one, x would be 30 degrees, which is pi over 6. So that's my first solution. The second possibility, you're going to add the 1 to both sides, and where is the sine of x equal to 1? Think about the unit circle. The sine is the y coordinate. Where is the y coordinate equal to 1? At 90 degrees, or pi over 2. Once again, sine is positive in both quadrant 1 and quadrant 2. So going back to sine being pi over 6, my reference angle here is pi over 6, or 30 degrees. So I want to figure out what turn is going to take me to there. So what you can do is do pi, which is a half turn, remove the pi over 6, and that gives you 5 pi over 6. Just get your common denominator here, and that's how I'm getting 5 pi over 6. And within this interval, the only place where the sine of x is equal to 1 is at pi over 2. So I have 3 solutions: pi over 6, 5 pi over 6, and pi over 2. Example 5. We want to solve this on the interval 0 to 2 pi. the first thing you want to do is add the 3 to both sides, then divide by 4. So we get the cosine squared of x is equal to 3/4. Now take the square root of both sides. So the cosine of x is equal to, remember to do plus or minus whenever you take the square root of both sides. And how did I get this from this? I was taking the square root, two solutions, plus or minus, the square root cancels the square. The square root of 3 is the square root of 3, but the square root of 4 is 2. So we have to figure out where is the cosine radical 3 over 2. Once again, refer to your triangle. Cosine is adjacent over hypotenuse. So it's 30 degrees, which is pi over 6. Now, because we have either positive or negative, and we're in the interval 0 to 2 pi, which means one turn around the circle, we're going to be in quadrants 1, 2, 3, and 4, because we can have positive, which would be here and here, because that's where the x coordinate is positive, or we could have negative, which would be here and here. So I've got pi over 6. To get this, 5 pi over 6, I want to take, just like I did in this last one, pi minus pi over 6 is 5 pi over 6. To get quadrant 3, if my reference angle is pi over 6, I take pi plus pi over 6. That's how I'm getting this. And to get the one in quadrant 4, I'm taking 2 pi minus the reference angle of pi over 6, and that's how I'm getting 11 pi over 6. So once again, these reference angles are all the same, even though it's not drawn to scale. They're all pi over 6. And example 6, we want to solve